Okay, now we're gonna try to find the limit of f of x as x goes to 1 from the right. So our function is defined by the square root of x minus 1 plus the natural log of x minus 1 minus x minus 1 squared over the square root of x minus 1 minus the natural log of x minus 1 plus x minus 1 squared. Okay, the first thing that we have to make sure of is that where our function is defined. Okay, I will leave you that so you can do it by yourself. So we can prove that this value here, or the denominator, is never 0 for all x bigger than 1. Okay, so that means our domain is 1 plus infinity. You can easily prove this fact here. And next we're gonna see the limit. So we can go and blindly evaluate. So here we get 0. Here when x goes to 1 from the right, we get minus infinity, and here we get 0. So let me rewrite it here. So we get 0 minus infinity minus 0 over 0 plus infinity plus 0. Therefore, we have minus infinity over infinity. So we can't say anything. And also, we can't apply the L'Hospital's rule here, because we need to have either minus infinity over minus infinity or plus infinity over infinity. Or we can rewrite this one in a form that we can use L'Hospital's rule. But that's not a big problem, because we can rewrite this one in a different manner. So try to rewrite it, stop the video, and work this problem. It's good to start working with this one. But a hint is, if you have an army and you have a weakest or the weakest soldier, try to get rid of him. He makes your army weak. Okay, stop the video and work this problem by yourself. Okay, now let's solve this problem. So here we see that in this kind of problems, we see that if we divide everything by the square root of x minus 1, we're gonna have 1 here on top, on the bottom, and also this one is still gonna have the plus infinity over minus infinity. That's the issue here. Okay, if we divide by x minus 1 squared, we're still gonna have the problem. The only option that we have is that when we have a competition between the log and the exponent and the power always wins. So the natural log is the weakest link. So therefore we have to get rid of him. Okay, sorry log. Okay, let's factor out by the log here. So once we do that, we're gonna have this written as the natural log of x minus 1 on top and bottom. Okay, and I will say why we're gonna cancel that. So we have 1, okay, plus no, we have the not 1, we have the square root of x minus 1 over the natural log of x minus 1 plus 1 minus x minus 1 squared over the natural log of x minus 1. And in the bottom, we're going to have the square root of x minus 1 over the natural log of x minus 1. Minus 1 plus x minus 1 squared over the natural log of x minus 1. Okay, now we can get rid of this because this is never 0. Okay, it doesn't matter if it's positive or negative, but it's never 0. So therefore we cancel this one without worrying about the issue. So now the limit becomes in this form. So the limit as x goes to 1 from the right of the square root of x minus 1 over the natural log of x minus 1 plus 1 minus x minus 1 squared over the natural log of x minus 1 over the square root of x minus 1 over the natural log of x minus 1 minus 1 plus x minus 1 squared over the natural log of x minus 1. Okay, now we do the evaluation. Okay, so what's this limit here? So when x goes to 1 from the right, we're gonna have so square root of x minus 1 over ln of x minus 1. So when x goes to 1 from the right, so we're gonna have 0 here over minus infinity, which is 0. So this is 0. And this one here, the same thing, okay? The limit as x minus 1 squared over the natural log of x minus 1. So as x goes to plus 1 from the right, so it's going to be 0 over minus infinity, which is 0. Therefore, we see that when we evaluate, we're going to have 0 plus 0, 0 plus 1 plus 0 over 0 minus 1 plus 0. Therefore, we have 1 over minus 1. And therefore, this limit is just minus 1. Okay? So we can't apply L'Hospital's rule, but a rewriting of the function gives us a hint how to solve it. So this is a good problem. So it's going to teach you how to solve these kind of questions. And also, you need to prove that the denominator is never 0. Okay? And it's defined for x bigger than 1. Prove this one, and I think that's it. Thank you very much.